Hello, scholars. So today we're going to take a look at solving quadratic equations by factoring. So this is our big concept. Number 3. Learning target. I am learning to write quadratic equations in standard form, and I am learning to solve quadratic equations by factoring. So first, let's take a look at the difference between standard form and factored form. Standard form is ax squared plus bx plus c, while the factor form is a times the quantity x minus p, x minus q. Notice the only thing they really both have in common is the a and the x's. So for instance here, I have two examples here that are the same equation. One is just factored form and the other is standard form. So the standard form says f of x equals x squared minus 8x plus 12, while the factored form is f of x equals x minus 6 times quantity x minus 2. So this is where we're actually going to start talking about those multiplying of binomial terms. When you multiply binomial terms, you're going to use the distributive property to multiply each term in the first set of parentheses by each term in the second set of parentheses. So here's that same factored form. I'm going to take the first x I have here and multiply it by the first x here. So now I have x times x. Then I'm going to go x times negative 2, which gets me a positive x times a negative 2. Next, I'll go the second term times the first term. So negative 6 times x. And then we'll have the last and the last. So we have negative 6 times negative 2. All right, so I color-coded it so you can see how we got each term. X times x yields an x squared. X times negative 2 gets us negative 2x. Negative 6 times x gets us negative 6x. And negative 6 times negative 2 gets us that positive 12. So we can simplify this just a tad bit more. If you realize these middle terms, negative 2x and minus 6x, actually do simplify. So what we get as a final answer is x squared minus 8x plus 12, which, if you realize, is that exact standard form. So here we just went from factored form to standard form. You can work backwards from each. So using that same multiplying of binomials, let's go ahead and take a look here. I'm not going to do it this time with the color code. So we have 2x times 3x, 2x times negative 6, 5 times 3x, and 5 times negative 6. So 2x times 3x is 6x squared. 2x times negative 6 is negative 12x. 5 times 3x is plus 15x. 5 times negative 6 is negative 30. So now, just like before, these middle terms are going to simplify out. We get 6x squared plus 3x minus 30. So there's the standard form of this expression. So now, these factored forms actually give us what we call roots. So write a quadratic equation in standard form with negative 1/3 and positive 6 as its root. So we actually go x minus negative 1/3, x minus 6. Let's try to write this a little better. And that is because these are the roots, but the standard or the factor form already has a minus in it. So now let's distribute. So we get x times x, which is x squared, x times negative 6, which is negative 6x, negative 1/3 times x, which is negative 1/3 x, and negative 1/3 times negative 6, which is a positive 2. Just like before, these middle terms are going to simplify. We get x squared minus 17/3 x plus 2. Now, I don't know about y'all, but I'm not the happiest when I have fractions. So one way to get rid of that fraction is to multiply the whole thing by 3. When we multiply the whole thing by 3, we get 3 times x squared, which is 3x squared. These 3's will cancel there, so minus 17x. And then we have a plus 6. So right here becomes that factored form, or that standard form. My apologies. With those as my roots. All right, now we're going to take a look at factoring. Factoring is where you take standard form and you work it backwards to get the factored form. And there are several different ways to go about factoring. The first way we're going to take a look at is factoring by a GCF, which is a greatest common factor. So I have to look at each term in my expression and see what is the largest number and variable I can pull from every single term. So when I look at the 16x squared plus 8x, I have to look at first the coefficient of each term and then its variable term. So 16 and 8. The best way is to look at the smallest number, 8. Does 8 go into 16? Yes. So we know 8 is a factor, is a greatest common factor between the two. All right, now we have x squared and x. I have 2 here, 1 here. How many can I take away from each? Well, I can't take more than 1, so I can take only 1. Now, 16 divided by 8 is 2. I have 2 x's here, 1 x here, so 2 minus 1 is 1. 8 divided by 8 is 1. I have 1 x here, 1 x here, so 1x minus 1x is 0. So now that is my factored form. But now we have to solve each equation. To solve each equation, you take each of the factors and you set them equal to 0. So 8x equals 0, 2x plus 1 equals 0. So when we simplify, we divide both sides here by 8, and we get x equals 0. On this side, we have to subtract the 1, and we get 2x equals negative 1. Divide both sides by 2, and x equals negative 1/2. So now we used factoring to solve each of these equations. In fact, we used the greatest common factor. All right, so now taking a look here, we have 21x squared minus 14x equals 0. Let's look at 14. Does 14 go into 21? No. So I'm going to take 14 and I'm going to list its factors. 1 and 14, 2 and 7. I know that 14 was not a factor, so I'm going to cross it out. Does 7 go into 14? Yes. Does 7 go into 21? Yes. 7 is going to be that GCF. So I pull out the 7. I have 2 x's here and 1 x here. Which is the smallest? 1x. So that's what I'm going to pull. So now, 21 divided by 7 is 3. I have 2 x's here, 1 x here. 2 minus 1 is 1, so I have only 1 x. Negative 14 divided by 7 is negative 2. X divided by x, 1 minus 1, no x's left. Still equals 0. Set each part equal to 0. Here, divide both sides by 7. x equals 0. On this side, we have to get rid of a minus 2, so we're going to add it to both sides. We're left with 3x equals 2. I need to isolate that x variable, so I divide both sides by what is being multiplied by x. In this case, it is the 3. And I have x equals 2/3. So those are my two solutions there. Now, like I said before, there are tons of different types of factoring. We're going to take a look at the special ones. When factoring, look for special types of quadratic polynomials because it will save you so much time. You really need to recognize this. This is one of the things that will save you so much time when you go to take the ACT because each one of these will be on the ACT in some way, shape, or form. So the difference of squares is exactly what it sounds like. You have two perfect squares that are being subtracted. When that happens, you take the square root of the a square, you take the square root of the b square, and you put a plus b, a minus b. One addition, one subtraction. The sum of squares is exactly what it sounds like. You're adding perfect squares. But here we have a plus bi, a minus bi. If you notice, those are the complex conjugates that we've talked about. And then we have what we call a perfect square trinomial. This is the one that if you recognize that you have a perfect square here, a perfect square here, and then 2 times the a's and b's, they turn out very beautiful. It's either going to be a minus b times a minus b or a plus b times a plus b. So let's take a look. We have an x squared, which is a perfect square. We have 64, which is a perfect square. Well, the square root of 64 is 8. So if we double that, double the 8, we get the 16. So it's x plus 8, x plus 8. You take the square root of this term, stick it here. Take the square root of this term, stick it here. That only works if when you add these two 8s, it gets you that middle term. All right, notice this one says x squared equals 64. We can't do anything with that. All of our quadratics have to equal 0. So we move it. And now it does equal 0. I have a perfect square minus a perfect square. According to our chart up above, we just take the square root of each term and do 1 plus and 1 minus. So this one was a perfect square trinomial. This one was a difference of squares. So what do you think this last one's going to be, just by process of elimination? It is, in fact, a sum of squares. I have a perfect square here and a perfect square here. I take the square root of each. X plus, x minus, 15i, 15i. And that's it. Oh, well, we factored them. We didn't actually solve. So this one, x plus 8 equals 0. So x equals negative 8. And we have that twice. This one, x plus 8 equals 0. So x equals negative 8. This one, x minus 8 equals 0. So x equals positive 8. X plus 15i equals 0. So x equals negative 15i. X minus 15i equals 0. So x equals 15i. So now we've solved all three of those equations. Now, if you can't factor by a GCF, and you can't recognize whether it's a special case, we have what we call the AC method. And the AC method has lots and lots and lots of steps. First thing, every time you every single time you factor, you always want to check for that GCF. If there's one, divide it out. All right, then you're going to identify your A, B's, and C's. You'll multiply A and you'll multiply C. Whatever product you get from A times C, you're going to list all the factors of it and see which of those factors sum to B, aka which of them add to B. Then you'll split the B term into the selected factors of AC, factor by grouping, and then solve for X. Here's some sign rules. Always look to the second sign to determine what's going on. So here my second sign is positive. If your second sign is positive, that means both of your signs are the same, and it's going to be whatever the first sign was. So in this case, it says both signs are the same, and they're both positive. This one says both of my signs are negative, or both my signs are different. I'm going to have one positive and one negative. So I'm going to look at that B term. Because B is positive, the largest factor will be the positive number. Here again, we have a positive. I look back to the first sign. They're both negatives. And then lastly, I have a minus, which means they're both going to be different. But because this B is negative, the largest factor will be negative. So let's look at some examples. The first step is find that GCF. Well, my coefficient is 1 and 20. Anytime you're going to have a leading coefficient of 1, you will not have a GCF. So next, I want you to identify A, B, and C. So A equals 1, B equals 9, and C equals 20. A, B, C. So now, you're going to multiply A and C. So A times C equals 1 times 20. So 20. And then B equals 9. So we're going to look at factors of 20 that when added get us 9. So I have this nice little chart to help us. Factors of 20. 1 and 20. 2 and 10. 4 and 5. So 1 plus 20 equals 21. So that doesn't work. 2 plus 10 equals 12. That doesn't work. 4 plus 5 equals 9. That one works. That one is our shooting star right here. So I'm going to make sure I take that one out. And so I'm going to go back here and I'm going to write my original expression. X squared plus 9x plus 20. I'm now going to split up the 9x into the factors of AC that I chose. I bring down my x squared, but now I have plus 4x plus 5x plus 20. Now we're going to do the factor by grouping. So I take the first two terms and I find the GCF of my first two terms. All right, the GCF of the first two terms. Well, this has no leading coefficient, so the only thing I can pull out is an x. When I pull out an x, I add 2 here, 1 here, so 2 minus 1 is just 1. 4 divided by 1, because there's a 1 here, I just don't see it, is 4. I have x divided by x, so 1x minus 1x is just x, or just 4. All right, now I have to look at the second half and do the same thing. We're going to find the GCF. So the GCF of 5 and 20, will this 5 go into 20? Yes, it does. So I'm going to pull out a 5. Do they both have x terms? No, so I can't pull out an x. So 5 divided by 5 is a 1, and I'm left over with the x. 20 divided by 5 is a 4. So here's the thing. If you did this correctly, the inside parts of your parentheses will match. And you'll rewrite it one time. And then you take the x plus 5 and you stick it out front. So those are the two factors. That is my factored form. So here we had our standard form. Here's my factored form. But it asked us to solve the equation. So x plus 5 equals 0. X plus 4 equals 0. So x equals that negative 5, and x equals that negative 4. So that is my factored form. All right, we're just going to do 3 more examples because this is very important. All right, first, check for a GCF. I don't have a GCF between 6, 23, and 20. 23 is a prime number. I don't have variables in each, so I can't pull out a variable. So here we have a equals 6, b equals negative 23, and c equals 20. Notice the second sign is positive, which means I'm only going to have negative factors. So when I have a times c equals 6 times 20, which is 120, I know that I'm only going to be looking at the factors of 120 that are negative, which means a negative times a negative will get me that positive. And then my b is that negative 23. So I have negative 1 times negative 120, negative 2 times negative 60, negative 3 times negative 40, negative 4 times negative 30, negative 5 times negative 24, negative 6 times negative 20, negative 7 doesn't work, negative 8 doesn't, or negative 8 actually does work. It was just negative 15. And then I can keep going. I got negative 10 and negative 12. And then our next factor would be negative 12. And we'd just go right back up what we've already have listed. So now let's see what happens when we add these. Negative 1 plus negative 120 is negative 121. Negative 2 plus negative 60 is negative 62. Negative 3 plus negative 40 is negative 43. This one gets us negative 34, negative 29. We're getting closer. Negative 26, negative 23. So I know that these right here are the factors that I'm going to use. So I'll come up here. I have 6y squared minus 23y plus 20 equals 0. That negative 23 is going to be split up in negative 8 and negative 15. So 6y squared minus 8y minus 15y plus 20 equals 0. All right, so now we're going to do the factor by grouping. We're just going to look at these first two terms. What can I pull from each of those? 6 and 8. What is the biggest number that can pull out of 6 and 8? If you said 2, you'd be absolutely correct. We have a y squared and a y, which means y is my smallest. I can pull out a y from each. When that happens, I'm left with 3 minus 4. 6 divided by 2 is 3. Y squared divided by y. 2 minus 1 is 1y. Negative 8 divided by positive 2 is negative 4. And y divided by y, they cancel, which is why I don't have a y term there. All right, because this is minus, this one's going to be minus. So minus, okay, what is the GCF between 15 and 20? 5. So we're going to pull out that 5. And we're left with, oops, I don't want to. All right, negative 15 divided by negative 5 is 3. 20 divided by negative 5 is negative 4 equals 0. Notice, once again, these parts match, which means I did it right. So my answer becomes 2y minus 5 times 3y minus 4 equals 0. Now I have to solve each piece by setting each piece equal to 0. So 2y minus 5 equals 0. We add 5 to both sides. Two y equals 5, so y equals 5 halves. And then over here we have 3y minus 4 equals 0. 3y equals 4 because we added 4 to both sides. Divide both sides by 3, y equals 4/3. All right, so those were those answers. Ooh, what don't I like about this example? My leading coefficient is negative. So to get rid of that negative, I'm going to divide every single term by negative 1. That'll give me a positive 12x squared minus 8x minus 15 equals 0. So now we have to factor it out. So A equals 12, B equals negative 8, C equals negative 15. So A times C equals 12 times negative 15, which in this case gets us a large number of negative 180. Then we have our B term, which equals negative 8. So we need to find the factors of negative 180. That'll get us a negative 8. Now this is where knowing our sign rules will really help us. We know, based on this, that they're going to be different and the larger number is going to be negative. So right now, I'm not going to focus on both the negative and positive aspects of what gets me negative 180. Because if that were to happen, I'd have negative 180 times positive 1 and positive 180 times a negative 1. So I'd have to list out twice as many factors as I needed. So what we'll do is we'll just 1 and 180, 2 and 90, 3 and 60, 4 and 45, 5 and 36, 6 and 30, 7 doesn't work, 8 doesn't work, 9 and 20, 10 and 18, and I could keep going, but what I notice is if I have this 10 and this 18, we know that my larger number is going to be the negative 1. So all these are the negatives. So I get 1 plus negative 180 is negative 179. And we keep going, and when we get 10 plus negative 18, we get negative 8. So these are the factors that I'm going to use. So now I go to 12x squared minus 8x minus 15. I separate that negative 8 out, so I have 12x squared plus 10x minus 18x minus 15. I'm going to do the GCF of my first two terms. 12 and 10, the only GCF I have between those are 2. X squared and x, I have a 2x. So 12 divided by 2 is 6. X squared divided by x is x. 10 divided by 2 is 5. X divided by x, they cancel. All right, now the next half. I'm going to use that minus. The GCF between 18 and 15, and yeah, your calculators will do this, is 3. So I pull out a 3, I'm left with 6x plus 5. Once again, They match. We did it correct. So now we have 2x minus 3 times 6x plus 5. And we'll go ahead and set each piece equal to 0. All right, so we get 2x equals 3, x equals 3 halves, 6x equals negative 5, so x equals negative 5/6. All right, so taking a look, I already have a 30-minute video, so we're just going to skip this last example and stop it here because 30 minutes is already long enough. All right, if you have any questions, please make sure to ask. This concept, factoring, is something that you will keep using all year long. You'll use it next year in pre-cal and whatever math class you take after this. So if you do have questions, make sure you are asking. Make sure you show up to virtual class so I can keep on doing examples with you. Have a great day.